VI. What is the pH at equivalence point?
Yeah. 7.
Okay. So here's what we're going to do is at equivalence point, we have OH minus plus Hochul gives me Hochul minus and water. Our hydroxide concentration at equivalence point is 0.0084, which is the same as Hochul. And we have a 0. Subtract from both sides. Or subtract and add. And after the war, what is left standing is Hochul. Did you say that? Did you say Iron Man?
There is no.
Yes, I keep thinking that every single time.
All right, so Hochul's left over. How are we going to find pH? If you have a salt, how do you find? So we're in a what kind of situation are we in? We're in a hydrolysis, right? So let's go ahead and divide this by our total amount that's in our beaker. So we had 42 and 24, so we have a 0.066 liters. 0.127 molarity. Now we're ready to go into hydrolysis. Wait, what's the question? You got a question? Okay, so we found our molarity of our weak acid, or our hydrolysis, our salt. Yes?
When you do hydrolysis, is it always like a forward, backward?
Yes. Or anytime we take a weak acid and add it to water, it's going to be like that. So now we have our molarity is 0.127. Water goes away. Hochul and hydroxide are 0. We subtract and add X to both sides. X is negligible. And now we're ready to solve.
We have a quiz on Monday, right?
Yes. Yeah, okay, so now how are we going to solve for X? KB, but we are given KA. So 1.0 times 10 to the minus 14 over 3.5 times 10 to the minus 8. So X at this point, which is equal to our hydroxide concentration, is what? One 1.90 times 10 to the negative 4 moles per liter, which means our POH is 3.72, and our pH therefore is 10.28. Questions on that one? So when you have a weak acid titrating with a strong base, or a weak base titrating with a strong acid, you're going to have to go into a hydrolysis at the end. Yes?
But if you have a strong acid and a weak acid, or a strong
Strong always wins.
But they have to do the same. Like base and base, right?
Yes.
Cool. Okay.
Okay. So now it says, what is our pH after we added 5 past equivalence point? So let's invade our Hochul with our hydroxide. We start out with 0.0084 of our Hochul moles. Our hydroxide is going to be 47 mils times the 0.2 molar. So 0.0094 moles. This time, Hochul runs out first. And plus 0.0084. So after the war, we are left standing with hydroxide and Hochul. So how do we calculate pH? We're going to use hydroxide molarity, right? So we have the moles of hydroxide divided by the total milliliters or liters, which would be, we had 72? 71. 24 of the acid is in there. And then we added 42 of the base and then 5 on top of that. 71. 0.071 liters. So my molarity of hydroxide ends up being 0.014.
I have a question. We'll only use the Hasselbalch equation if it's a buffer, right?
Right.
Okay, and that's if it gives us Ka.
Right. Or you found it. Yes.
Okay, sorry.
Okay. So pH at this point, POH is 1.85, and therefore pH is 12.15. And then it wants us to sketch it, so bear with me. We are going to have our pH, and then we are going to have our mils of NaOH. That's what's in our burette. That's what we're titrating with. So I'm going to put 14 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay. So I'm going to go back all the way to the beginning and see what our pH that we started with. And our beginning pH was 3.96. So 1, 2, 3. About right there is where we're starting. Let me get black instead. All right. So we're going to start about right there. We add 5 mils, and when we add 5 mils, we go up to 6.5, 6.59. So we're about right there. Now we've added 15 mils, and we go up to 7.2, 5, 10, 15, which is about right there.
Is that at the 20 or the 15?
That's at the 15, because it's 15 total.
Okay.
And then we add 25 total, and that means 5, 10, 15, 20. We're at 7.62. And then we go to, is it 8? At 35 milliliters, we're at 8 something, 8.15. So at 35, 5, 10, 15, 20, 25, 35, we are at 8.15. And then at equivalence point at 42, we are at 10.28. 7, 8. So about right there. And then after we go past that, we are at 12 something.
But that's exciting, right?
So this kind of looks like this. The curve kind of looks like that. I need you to know several parts of this curve. And it asked you on your titration problems last night. So this part right here in there, that's our buffer region. That's kind of a bad curve. So right in here is our buffer region.
So before
Kind of about when it starts to curve and then when it goes to that sharp curve. All right, halfway to our equivalence point. In here it was 42, so it would be about 21. So 5, 10, 15, 20. So right here, halfway to the equivalence point is called half equivalence point. So halfway is called half equivalence point or midpoint. What is so important about this is where our pH is equal to our pKa. Okay? So at 21, we'll go over there. We'll see where that is on the graph, that pH. Take the 10 to the power of it, and that will give us our Ka value. So try that. That's about at, what, 7.5? So put it in your calculator. Take 10 to the power of 7.5 and see what you come up with. 10 to the negative, yes. 3.16 times 10 to the negative 8. What did we say our Ka was at the beginning of this? 3.5 times 10 to the negative 8. So it's really close. Also here, you need to realize that your equivalence point, our equivalence point does not equal 0. Our equivalence point does not equal 0, or 7, does not equal 7. Because, what's it equal? Our equivalence point was 10 something. Why is it our equivalence point basic? Because it's a weak acid with being titrated with a strong base. If we were to do a weak base with a strong acid, our curve would be opposite of what we're seeing right now.
I'm sorry. Where did you get the 7.5?
I went to the 21. I went to halfway to my equivalence point. My equivalence point was at 42. And I went halfway of that, which is 21. And I went to see what the pH is.
On the other pH graph that we made,
Uh-huh.
where did the buffer region be?
There is no buffer region.
Okay.
Okay.
If it's a stronger equivalent, it would be a buffer
Right.
region.
If it's strong, strong, no buffer region. Okay?
Only if it's strong or weak? And weak, I'm sorry.
Yes. Strong, strong, no buffer region because it goes straight to 7. Okay? All right, so let's compare these, and then we are done. We're ready to work on the sort. Okay, so what can we say about weak strong versus strong strong? What can we say about the start? I would say that the weak has a, well, I would say the strong strong has an extreme start, right? We're way down there. And then it just jumps up. So I would say the weak is not as extreme start. We started at like 3 something. I would say that we have a very sharp rise in our strong strong. And our weak strong is not as sharp rise. And our rise also isn't as long as high as our strong strong. Equivalence point in a weak strong is going to be not equal to 7, whereas with the strong strong, equivalence point always equals 7. And lastly, remember, in the weak strong, your half equivalence point equals your pKa. Or equals, yeah, your pKa.
So when you say rise, like for number 3, it's not rising, it's decreasing. It's going down.
Okay, so then did it rise or your decrease? I don't have it in front of me. It's just the opposite.
Oh, okay.
Okay, so rather than rise, then the fall, whatever. Okay. All right, are there any questions on those? Being able to look at them and know what's going on, being able to identify the graph.
So we're saying that half equivalence points pH is equal to pH.
Yes, the pH at half equivalence. Okay. Oops. So.